Hello everyone. Today we're gonna solve new LeetCode problem. The problem is 146 LRU cache. And we need to design a data structure that follows the constraints of a least recently used cache. We need to implement this main class. It's called LRU cache. We have here initialization, getting. If you don't have, if key does not exist, we return -1 and put element. If we exceed capacity, we just replace it. We delete the least recently used key, and everything should work in constant time. Here is some examples. Capacity, pretty popular problem. And my idea here is to use some new class that I will call list node. And we will have here key, value, new pointer to previous element. Let's see from next, and for previous, and some constructor. For key and value. The main class I'm going to use to map, where I will store key as integer, and my newly created class list node as value. Capacity variable where I'm gonna store our capacity, list node for head, and for tail, because I'm going to use double linked list. Okay. Then I set my capacity. Initialize head as -1. And tail is the same with -1. Then head. Just I think I can do it like this. And here head next to the tail. And tail previous will be head. Okay. Also, I'm going to have to support method and add and remove based on list node. Okay, now if I am going to get element by key, first I have to check if my map does not contain this key. I will return just -1. Otherwise, I think I have to remove, then add, and then return node value. But before, if I previously checked that I don't have this value, map I return it, but in this case, after this condition, I'm sure that I have this value and I can just get it by key. Then I remove it and add it again to my linked list. Because in this case, I will refresh this position of least recently used key. Okay, in case if I'm going to put it, if my map contains this key, I take this node from my map and remove it from linked list. Then I create new nodes with key and value. Then I add it. And if, and of course, store it to my map, key node. And if map size is greater than capacity, in this case, I remove it from linked list and remove it from map. Okay, removing will be looking like I take my node. Okay, next, and I need to set this next element. So I should take node previous next and map it to next element after my node. And then I should take my next element and map previous to node previous. In this case, I will get rid of this middle node that I'm going to remove. In case of adding new elements, okay, in case of adding new element, I need to take previous tail. Then previous tail next will be node. Tail previous will be node. Node next will be tail. So previous tail will be looking for as next element for our nodes we're gonna insert. Tell your tail previous to node. Node next to tail. No, pointer exception 163. Yes, mistake somewhere in add method, but I didn't set something. Not previous. Should be previous tail. Okay. We created new map with capacity 2. Then we're gonna put 1 with key 1. Okay. If our map contains, we remove it. Create new list node. Add it to our linked list. Okay, then we put 2, we have 1, 2. Then we get 1. Let's return it 1. Then we try to insert 3. And we are trying to take 2. And 2 must be removed. And we should return -1. Then insert 4, in this case 1 must be removed. Return -1. Let's get 3 format list state. Okay. So we put 1, 2. Initially our map looks like empty. Link list -1 head and -1 tail. Then we insert 1 and 2. Our map has something, will look something like this. Then we take 1, yes, we have it. Then we insert 3. And we trying to get 2, so 2 must be removed. And our linked list, if we add tail, it will look like something like this. So when we want to insert 3, we should remove 2. Because we get 1, we have it like this. And then when we insert put, we removed head. Okay. But how it looks like 2, 1, -1. Okay, here she probably should remove head. Maybe even head next. Okay, here's the previous. It's our head at first iteration. And then we are trying to make it next. So insert in first iteration, insert value between head and tail. Then insert between tail and second element. And if we remove head next. For example, it's first iteration, take tail here and replace node head next to tail and node next tail previous to head. Yes, okay. Okay, probably I should remove it from map somehow. How I can remove it from map? If I have head next, I probably can do it. Minus. Head next value. Okay, now it looks better. Tricky. So key can be different than value. I have key instead of value. Because in my model I store key and value. Yep. Like 20 minutes. I still have 10 minutes. Okay, I think time complexity and space complexity. About space complexity, it's ON because we have extra memory for map. About time complexity, it's constant because of map and linked list. Map, I just take it in a constant time, and in list, because I didn't go through the whole list, I just replace links for elements that I already know. It's to constant time. So I even don't know how I can improve it without using extra memory. It's not possible here. Thank you for watching.